Hello, welcome to episode 1 of the Mr. Rationality YouTube channel. I'm Thomas Yale. In this video, as a mental exercise, I'll be addressing the topic of hydrogen cars. Is there such a thing as a hydrogen vehicle or a water-fueled car? Are they good for the environment, and do they help in reducing our collective carbon footprint? The issue of climate change is the subject of a whole other video. For now, we'll proceed on the premise that climate change is a real phenomenon and is detrimental to our environment. Before I go on, I'd like to issue a caveat, something that may interfere with our clear thinking and prevent us from examining the topic with anything other than complete objectivity. And it is this: the usefulness of an idea is not based on how unique or exotic that idea may be, but rather on the concrete results we obtain from using that idea in actual practice. That usefulness is also based upon whether that idea's advantages outweigh any possible disadvantages. To find out these things involves a little research and the logic necessary in order to interpret it. So first, is there such a thing as a hydrogen vehicle? As of 2016, 3 are commercially available on the market, and other companies are working to produce other models. They certainly appeal to car buyers who have environmental concerns and want to do what they can to be environmentally friendly as they go about their daily lives. Fueling not only cars but other machinery with hydrogen, like the recent Koradia Island train in Germany, which will launch the first ever passenger hydrogen-powered rail service, does have advantages. It burns with oxygen to make water vapor, with no nitrous oxides, methane, phosphorus, or carbon dioxide to add to the greenhouse gases already in the atmosphere. But in implementing this idea, we can't overlook the disadvantages. Hydrogen is not a source of energy. It may be the most abundant element in the universe, but there are no direct sources of hydrogen gas on Earth. It has to be manufactured. As of 2014, 95% of hydrogen is made from natural gas, which upon combustion releases methane, a greenhouse gas. Billions of tons of carbon dioxide are dumped into the atmosphere every year from facilities that produce hydrogen by burning fossil fuels like coal, oil, and natural gas. Even in its densest form, as a liquid, hydrogen has only 1/3 as much energy per liter or gallon as gasoline. If it's stored as a compressed gas at 300 atmospheres, that efficiency goes down, delivering less than 1/5 of the energy per volume of gasoline, which means that with the low energy density, fuel storage takes up lots of room in a hydrogen-powered car. Reducing the amount of storage room would require a huge investment in infrastructure to build the hydrogen fueling stations to be put in service, outstripping the already huge number of gasoline stations, an option that might not be practical or profitable. Other disadvantages include capital cost burdens in the capture and compression of hydrogen, which also requires extra energy. So when you bear this in mind, however noble our intentions to be environmentally friendly by driving hydrogen-fueled cars, we may be unknowingly and inadvertently be harming the environment more by driving the gas-powered cars we want to take off our roads. Which brings us to the second question: is there such a thing as a water-powered car? Specifically, one that derives all its energy directly from water. Beyond the inner mechanisms involved, that would have advantages too. While hydrogen is the most abundant element in the universe, water is the most abundant chemical compound on Earth. It's recyclable. Once decomposed, whether by electrolysis or at high temperature, the oxygen and hydrogen recombine into water when they reach a lower temperature in the exhaust. And since water is chemically stable, the risk of explosion is practically non-existent. But let's take a look at the inner mechanisms. At our present level of science, there exists no way to extract chemical energy from water alone. Again, water is highly stable and has very strong chemical bonds. That means you have to have energy to break those bonds and extract the hydrogen. At this point, no energy is released in this way. Rather, it requires another source of energy to split or separate it. The most common method supposedly used in many hydrogen-powered cars since 1935 has been electrolysis. That's where water is decomposed by passing an electric current through the water. At best, the latest development in water splitting by electrolysis has been made in 2014 by Professor Hong-Jie Dai from Stanford University. He and his team of researchers have devised nickel-iron electrodes active enough to split water at room temperature with a single 1.5 volt battery. As promising as this seems, the law of conservation of energy still applies. However active they are, the electrocatalysts in this are unable to derive any more energy from this process than what is put into it. Energy can neither be created nor destroyed. It just transforms from one form to another. We haven't even addressed the problem of where the enormous amount of energy for the electrolysis even comes from. The car battery? Well, let's do the math. The typical car battery produces 12 volts at 40 amp hours, a total of 960 watt hours. Commercially available electrolysis systems require 50 kilowatt hours, 52 times that amount, to produce only 20 grams of hydrogen gas. Hydrogen furnishes 3 times as much energy per volume than gasoline. So the hydrogen output produced by a typical car battery would be 0.384 grams, the equivalent of only 0.0001015 gallons, or 0.07795 teaspoons of gasoline, with 3 times as much energy per volume. At 17 miles per gallon, that would propel a car 27 feet 3 inches. And that's only when you exhaust the entire energy capacity of the battery. Now, I'm not an engineer. I did the best I could with the figures I had available and exercised the best reasoning I could with the math. But if any engineers watching have spotted any flaws in my math or method, please know that I'd be more than happy to be called out on it, and your correction would be very much appreciated. As always, I like to learn. Which brings up another principle. A person may be wrong about something, or he simply may not know something. There's no shame in that. None of us know everything, and we all learn. Anyway, we still haven't addressed the mechanisms involved to extract the hydrogen, compress it, and inject it into the internal combustion engine. That would weigh down a typical car and proportionally reduce the distance to travel, assuming that I calculated it right, even further. There's a fine line between being negative and being factual. However disheartening this analysis may sound, the prospect of alternative energy isn't bleak at all. This is due to another principle I use. Never neglect to find other ways to look at an issue or problem. Here's one point we've overlooked. Why expend an inordinately huge amount of electricity to split water, extract the hydrogen, and use it to fuel the car with so little net efficiency? Wouldn't it make more sense not to bother producing the hydrogen at all and use the electricity to power the car instead? Of course, this is hardly a revolutionary idea. There are electrical cars out there already. Research is continuing on the quality of batteries and their energy density, extending the distance traveled on each charge. And assuming that the method to produce the electricity is a green option like solar, wind, or hydrocarbon, electric cars would produce no CO2 emissions at all. Something else to consider. Could there be other means of hydrogen production that don't produce greenhouse gases? Honestly, I don't know. I haven't seen any. Still, that doesn't discount electricity being a far more efficient fuel than hydrogen to power a car. Comments are always welcome, and to maintain legitimacy and scientific accuracy in this online venue, I ask that you also include links to reliable sources. Sources only serve to strengthen your position and establish your comment as factual. I'd also be open to update this video with any corrections, along with any regularly scheduled weekly video I'll be producing. In episode 2, we'll be discussing a touching, heartfelt letter that Albert Einstein wrote to his beloved daughter Lucille, who in the 1980s had donated this and other letters from her father to Hebrew University. Or maybe he never wrote it at all. I'll clear up that mystery next week. See you then.